Hey there! Here we go into some even more advanced partial fraction decomposition. What happens when we have quadratic factors? Oh my! Let's deal. So when we have quadratic factors like x squared plus 1 in there, we have to do a little bit of a different setup with our partial fractions. Now notice, the degree of the denominator would be x squared times x squared, which is x to the fourth. The numerator's third degree, so we're not going to use long division here. Just want to point that one out. All right, so how do we deal with this? Well, we notice that the bottom is factored. We split everything up, and there's going to be quite a bit of algebra in this, and we can handle it. We got this. All over, and there's a little bit more factoring to be done with this term. That's going to be x times x minus 2 times x squared plus 1. Okay, now, this is that new part where we split things up. It's going to be like normal. You're going to get a over x, like normal, plus some other constant b over x minus 2. And here, where you'd normally expect to do just c, you have to put cx plus d over x squared plus 1. You might say, why? Well, it's more so if we don't do it this way, we're not going to set ourselves up with something nice at all. We want this to act like something that is, well, use substitutable, if you will. Number one, and number two, if we don't set it up with that x value, we might not be able to get that same exact numerator back. So it's cx plus d that we put up there, not just some constant. All right, so that's very important. You have a linear term over a quadratic when you have quadratics. That's it. All right, so now how do we go from here and deal? Well, what we do is we keep going on like we've been doing before. Nothing new from this point on. Your setup was new, now nothing else is. So we multiply everything through by x times x minus 2 times x squared plus 1. When we do that, all of that divides out, and you're left with that massive nastiness right there on the left. And I promise you the numbers won't work out too badly. When you multiply through by all of this, the x cancels, and you're left with a times x minus 2 times x squared plus 1. Not bad. Plus b times, and then you're going to get the x minus 2's dropping, and you'll be left with x times x squared plus 1. Awesome. Plus, and then cx plus d times x squared plus 1. All right, now, when we look at this kind of thing here, it's a little bit gnarly in that things are not going to cancel out. Not everything will. So we're actually going to end up, I'm sorry to say, with a system of equations. So this is going to take some extra doing, and we got this. Now, if your teacher happens to go down this path, which many don't, but if they do, I've got you covered. So we're still going to pick x values that will cancel things out. Sorry, this also has an x minus 2 here. I almost forgot that. The x minus 2 would be here as well because it wasn't there to divide out. So we're still going to cancel out some things. So let me let x equal to 2. If x equals 2, a goes away and c and d go away. That zeroes out. And you're left with, okay, well, let's do out some math here. 2 cubed is, well, 8 times 6 is 48. This is going to end up being 44 when we plug in, so that's 4. Plus 28 is 32. Minus 2 is 30. Ooh. So you have 30 equals, and then we're going to plug in 2 here, and you're going to get 2 times 6. Sorry, 2 times 5 is what that's going to be. 2 and then 5. So it's 10b. Oh, that's nice. So b is equal to 3. All right, so we got b is equal to 3. It's going to be a lot of work here. Hang in there. A value over x. Let's do it. So how are we going to get to there? Well, we got to pick a value that cancels out other things here. And so what else is going to cancel out? And I'm realizing that as I did this part here, I had the wrong number that I put next to that one. So let me reverse just a little bit. Cx plus d, the x squared plus 1's will divide out. The x and the x minus 2 still remain. There we go. All right, so sorry for that little minor error there. So we're going to now plug in x equals 0. It's an easy number to plug in. It will eliminate b and cx and d, so that's good. So then when we plug in 0, we're just left with the a value, and all those cancel. You get minus 2 equals minus 2 times 1 is minus 2. Oh, nice. A is going to be equal to 1. As if I made this problem so the numbers work out nicely. Let's see if that continues. So here's where it gets a little bit gnarly. We unfortunately can't cancel out the x squared plus 1 terms. That's really unfortunate. So what we do know is we know what our a and b values are. We now need to plug in for c and d to be able to find those out. So we need two x values to do that because we have two variables, so we're going to need two equations. Sorry about that, guys. So number one, let's just plug in x equals 1, I guess would be a really nice number to plug in there. So we'll do x equals 1. Watch what we get there. 6 minus 11 is negative 5, and 14 is 9, minus 2 is 7. A, remember, is going to be 1. That's what that is. So A is 1, B is 3, and we're plugging in x equals 1. So negative 1 plus times 2 is negative 2 times 1 is negative 2. This is 3 times 1 is 3, times this will be 2 when you plug in 1, is 6. Plus, and now we're plugging in 1, so that's going to be negative 1. Negative 1 times 1 is negative 1. And this will be c plus d. So that's minus c plus d. Ugh. That is terrible. That is really, really bad. Let's keep going, though. We're going to now plug in x equals, it's nasty, right? X equals, let's go with, I think probably the best number to plug in at this point. Well, an easy one to plug in on that side would be like negative 1. So let's do that. You could also plug in 3 for the 2 right there, but we'll do negative 1. Negative 1 cubed, that's negative 6. And minus 11 is negative 17. Minus 14 is negative 31. Minus 33. So it's minus 33 is equal to, and you know what I'll do? I'm going to stack that right on top of here because you get minus 33 equals, now we're going to plug in negative 1. So it's going to be 1 times negative 3 is negative 3. And another 2 multiplied is going to be negative 6. Okay, we got that. And then this is negative 1 times 2 again. So that's negative 2 times 3 is negative 6. So another minus 6. Interesting. Now from here, we're going to plug in negative 1. That's going to give you a, well, minus c plus d right there. Let's see how that works out. So we've got minus 1 times a minus 3 is a positive 3. So plus 3 times negative 1 is a negative c plus d. Oh. All right. Now what we're going to do is we'll solve this thing out. It's a system of equations. I told you it's a nasty one. 7 equals, this is going to be 4 minus c minus d. This is negative 33 minus 12. We're going to bring the 12 over. That's going to be minus 21. And so this is going to be minus 3c plus 3d. And we'll keep solving that out. So you end up with c plus d, or c plus a negative d, is equal to 3, moving the 4 over. And here we get a negative 3c plus 3d is equal to negative 21. So after all that, and you have a system of equations. I'm really sorry. Here we go. So now from here, we're going to multiply through both sides by negative 3. This is all to just be able to integrate it, by the way. So we've got that negative 3 that we're going to multiply both sides by, or maybe just 3. We'll multiply both sides by 3. You'll get negative 3c minus 3d equals 9. All over, and then we'll have minus 3c plus 3d equals negative 21. And we'll add top and bottom here. So you end up with, well, negative 6c. You've got, that goes to 0, and 9 and negative 21 is negative 12. C is equal to negative 2. Okay. Sorry, positive 2. So C is equal to positive 2. That's good news. So we'll plug it into any one of these equations here. If C is positive 2, I get minus 2 minus D, plugging it into this one, equals 3. Minus D equals 5, and D equals negative 5. Dudes, if your professor or teacher makes you do this one, I'm so sorry. But I've got you covered. You've got A, B, C, and D now. So C is equal to, let's see, 2, and D is equal to negative 5. So here's the rough part. You do all that work and you think, oh, this part's easy. No, the integral's a little bit gross too. So what we now have is this new integral, and it is equal to 1 over x. So 1 over x, like so, plus 3 over x minus 2, plus, and here's what I'm going to do. I'm going to make this 2x over x squared plus 1 minus 5 over x squared plus 1. Now, I'm going to do these integrals out, where if you need help on any individual integral, you're going to have to go back to chapter 5 and chapter 4 to go over that, because each of these integrals are not bad. But man, if I go through this piece by piece, it's going to take another 10 minutes. So here we go. The integral of 1 over x is ln of the absolute value of x. The integral of this is also ln plus 3 ln of the absolute value of x minus 2. Now this one, you might notice, you could use u substitution, but the derivative of x squared plus 1 is 2x. So it's almost like I've got, and I guess I will do that off to the side. You've got a 2x over x squared plus 1 dx. U is equal to x squared plus 1. Du is equal to 2x dx. We're going to end up with, the integral of literally du over u, which is ln of the absolute value of u. So it's plus the ln of the absolute value of x squared plus 1. And we'll go to the next line here. This is arctan minus 5 over a, which is just 1, arctan of x plus c. That's a hard problem. And I got another one on the other side of this. We're not going to stop this video. Let's keep going. That is disgusting. It really is. But the core here is you're doing everything very similar, except it's cx plus d over the quadratic. And then you're going to realize that, unfortunately, you have to use a system of equations to solve it out. This next one, not going to be any nicer. So this is going to be a long video. But again, I'm covering those of you who might have these kinds of questions asked. And I really hope that you don't. Okay, so x cubed plus x over x squared plus 4 squared. We're going to rewrite that as x cubed plus x over x squared plus 4 times x squared plus 4. Right, so that's a repeated quadratic factor. Oh my indeed. Now, that is done in much the same way we did that previous one. Ax plus b over x squared plus 4. And then we have a whole different term that we have to do again. And that's going to be cx plus d all over, and then it would be x squared plus 4 squared. Right, so now we have everything written out like that, much like we did the repeated linear factors. Right, nothing different there. And now we're going to multiply through. This is probably possibly the worst one because the factors themselves can't be zeroed out. So we're going to multiply through by x squared plus 4 squared. And this is where we're going to use some magic, and I'll show you what I mean here. You're going to end up with x cubed plus x. That's ax plus b times an x squared plus 4 plus cx plus d, and it's just cx plus d. Now, you might look at this and say, what do you mean? What kind of magic could we do here? I'm going to use term-by-term analysis here rather than a massive system of equations like we did in the last one. So let me show you a different way of going about things. We've got x cubed plus x on the left, and that is equal to, and I'm going to FOIL this out, you'd get ax cubed right there. You'd get 4ax on the outside, plus bx squared on the inside, plus 4b, plus cx, plus d. Now, what I know is that if this left side is equal to this right side, then ax cubed must be equal to x cubed. That's true. And therefore, a has to be equal to the same coefficient. Because if that polynomial is equal to this one, then that coefficient is equal to the corresponding power, corresponding term with the same power is coefficient. So a is equal to 1. That's awesome. So we got a is equal to 1. We're going to do the same thing now with the x squared term. If you notice, we have only one x squared term. We have bx squared. Now bx squared, there is no x squared term. So that's got to be equal to 0, x squared. If there's no x squared term, it's 0. So therefore, b equals 0. Nice. And we'll keep going with this. If b is 0, by the way, this cancels out too, because b is 0. And so now we'll keep going. A is 1, right? So we found out that a was 1 just from that piece right there. And now 4x plus cx. That's what we have left. 4x plus cx. Again, a was 1. So 4x plus cx has to equal to the x term here. Well, now let's think about this. That means that cx is equal to negative 3x. So c has to be equal to negative 3. Isn't this a neat way about going things? And we could probably have worked it this way with the last problem, but I wanted to show you a different way of doing things, just in case your professor teaches it in different ways. And then d. Well, now we need to find d. Well, here's the thing. d is the only constant, and there is no constant. So therefore, d equals 0. because there's a 0 there. So d is 0. So all of that work, and look at what we get. We now have that the integral is equal to the integral of, that's just 1, so that's x over x squared plus 4. This is going to be minus 3x over x squared plus 4 squared. And now, as bad as all of this looked, it got a little bit nicer. We've got some u subs here. So I'm going to take each individual integral. So we'll do the integral of this one right here. So you get the integral of x over x squared plus 4 minus 3 times the integral of x over x squared plus 4 squared. Sweet. And what I'm going to do is I'm going to let u equal to x squared plus 4 here. So let's take all this work over here. So u equals x squared plus 4. du is going to be equal to 2x, and that's in both of those actually, technically. So how do we make a 2x? We've got a 2 here and a 1/2. So I'm going to end up with 1/2 the integral. 2x dx is du. So that's going to be just 1 over u. Nice. Minus, we're going to have the 3 integral, same exact substitutions actually. We want a 2x, so I put a 2 there over 2. So that's going to be minus 3/2. Again, we've got du over u squared, which would be u to the minus 2. It's the same as over u squared. All right, here we go. Need more room. So the integral of that is 1/2 ln of the absolute value of u. Well, what's this going to be? You get minus 3/2. U to the minus 2 becomes u to the minus 1. Divide by -1. There we go. And now we plug in for u. 1/2 ln of the absolute value of u, which was x squared plus 4. Ugh. This is tough. Plus 3 over 2. U to the -1 goes to the denominator. X squared plus 4. Plus c. So if you're looking at the end of this video and you're like, wow, my brain hurts. You're not alone. It's hard. Right? It's not easy. This involves a lot of algebra. This one involves some term-by-term analysis, which is very different. These kinds of problems are not for the faint of heart, and it's for those professors that go crazy with this stuff. But I got you covered, as always. I'll see you next time. Peace.